Hi, I'm Miss Letty, and welcome to this video in which we're going to be talking about the topic of work, power, and energy. In this video, we're going to be doing some exercises in which we're going to get a better idea of what these concepts are about. So let's get started, okay? First, we have work. Work has a unit of joules. Joules is also the unit of energy. And since they have the same unit, we're going to be sort of talking about them together later on. But for now, we're going to stick with work by itself. All right. So work has a formula of force times cosine of our angle times our distance. So in this exercise, we have that we are trying to find the work of the resultant force of a car that is moving on the x-axis. So let's get started. All right. First and foremost, we need to start out with our free body diagram. In our free body diagram, we have an applied force, which is the motor force. We have friction, which is going the opposite way. And we also have our vertical forces, which are weights and normal. Therefore, when we do the sum of our forces, we're going to get that the sum of our forces on the x-axis is our applied force minus our friction. And that is always equal to our mass times our acceleration. All right. Our applied force is 200 newtons. And we don't know our friction force just yet, but we do know that our mass is 50 kilograms. And our acceleration is 3 meters per second squared. Therefore, we can now isolate for our friction force, so 200 newtons minus our friction force equals 150 newtons. Therefore, our friction force is 50 newtons. Now that we have our friction force, we can get the work of our applied force and the work of our friction force. With that data, with that information, we can now get the work of the resultant force, all right? So first, we're gonna get the work of our applied force. Our applied force is 200 newtons times cosine of our angle, which is 0 degrees, times our distance, which is 5 meters. So 200 times cosine of 0, which is 1, times 5 would give us 1,000 joules, which is the unit that we said was going to be for work. Then we're going to have our work for our friction force, which is 50 newtons, times cosine of 180, times 5 meters. Therefore, that is 50 times cosine of 180, which is -1, times 5 would give us a -250 joules. Now, to get the resultant work, or the net work, we're going to have to do the sum of these two. Therefore, work of our resultant, or net work, it's the same thing, is equal to 750 joules. And with that, we have our answer. Okay? Next, we have power. In this exercise, we're trying to find power of the work from the resultant force of the previous exercise. So we already have the work. Our formula for power is work divided by time. So we already have all the data that we need essentially. So power equals 750 joules divided by our time, which is given right over here. So 30 seconds. Therefore, if we divide 750 divided by 30 is 25. The unit that we use for power is watts. So the W right here. All right, and that is our answer. Okay. Be careful here with our units. Our time always has to be in seconds. Our work is obviously in joules, our forces in newtons, and our mass in kilograms, distance in meters, etc. All right. And finally, we have energy. Now, energy is a really important topic, and it's really interesting to talk about the conservation of energy itself. We know that energy does not get destroyed or created, it only transforms, which is what we're going to be seeing in this problem, all right? So, in this problem, we're going to get the information from every single point in our roller coaster, okay? Starting out with the first one. Now, in energy, we have various types of energy. We have kinetic energy, which is the one for movement. Therefore, it is 1/2 times mass times our velocity squared. And we have our potential energy. Now, our potential energy, we can have two types. We have our gravitational potential energy, and we can have our spring potential energy. In this case, we're going to be talking about the gravitational potential energy, which has a formula of mass times gravity times height. All right. There's also another type of energy, which is the sum of these two. That is our mechanical energy. Our mechanical energy is kinetic energy plus our potential energy. Now, this one's going to help us out a lot because the mechanical energy is going to be exactly the same number at any given point. Okay? It has to be the same number. That's how we know that the energy is not created or destroyed. It just transforms between the different types of energy. Okay? So, here we go. In the very first point, so let's name that point A. We have a mass, 50 kilograms. So in that point A, we're going to get our kinetic energy, which is 1/2 times our mass, which is 50, times our velocity, which is given right here, 2 meters per second. And all of this has to be squared. All right, so if we try out 50 times 2 squared divided by 2 would give us 100. All right, and we can get the potential energy as well because we do have the height. Therefore, 50 kilograms times our gravity, which is 9.81 meters per second squared, times our height, which is 10 meters. So if we multiply 50 times 9.81 times 10 would give us 4,905 joules. All right. So now we have both of our energies. With that information, we can get our mechanical energy, which would be 4,905 plus 100, which is 5,005 joules. Okay? Now we got all that information from the very first point. But with that information, we're going to be able to get everything else. Okay? So every other point is a whole other different context. Okay? So in this very first context, in point A, we had a velocity, we had a height, therefore we had both energies. In point B, we don't really know the velocity. So if we try to do our formula, so 50 kilograms, we're going to get stuck at the velocity because we don't know it just yet. But in our potential energy, we know that that's 50 kilograms times 9.81 meters per second squared times our height, which in this case, we're all the way at the bottom on the ground. So that's going to be 0 meters. Therefore, my potential energy is 0. Okay? And we said before that the mechanical energy is going to be exactly the same at any point. Therefore, if I know that the sum has to be 5,005, my kinetic energy has to be 5,005 joules. So we can now isolate for our velocity. Therefore, we're going to do 5,005 divided by the information that we have right over here on this side. So divided by 50 times a half, which is 25. And then the square root of that, which would give us a velocity of 14.149 meters per second. Okay? And we got it. Point C. In point C, we have a height, therefore we are going to have a potential energy. So kinetic energy and potential energy and mechanical energy. My mechanical energy is exactly the same, 5 joules. My kinetic energy, 1/2 times 50 kilograms times my velocity, but I don't know my velocity. Okay, so I'm going to leave that there. And my potential energy, 50 kilograms times 9.81 meters per second squared times 3 meters. Therefore, I'm going to have to do 50 times 9.81 times 3. This would be 1,471.5 joules. Now, since the sum has to be 5,005 joules, and I already have that my potential energy is 1,471.5, then that means that the rest of it is going to be kinetic energy. 5 minus 471.5, which means that my kinetic energy would be 3,533.5. With that information, I can do just as I did before and isolate for my velocity. So that divided by our 25, and then the square root. Therefore, my velocity is 11.889 meters per second. Okay. And finally, in the very last point, we're looking for a maximum height. Therefore, at the maximum height, we can assume that our velocity is going to be 0. Just like in parabolic launch, vertical launch, where at the maximum height, we had our velocity of 0, same thing here. Therefore, my kinetic energy is 1/2 times 50 kilograms times my velocity, which is 0. Therefore, the whole thing is going to be 0. Okay? My potential energy, I don't know it just yet, but I'm going to get it. And my mechanical energy is the same, 5,005 joules. Okay? So, since the sum of them has to be the same, my potential energy is going to cover the whole thing. So, it's going to be 5,005 joules. So, 50 kilograms times 9.81 meters per second squared times my height, which I don't know just yet, is going to be 5,005 joules. So now I'm going to get to isolate for my height, which is what we want to get in this case. So we have 5,005 divided by 50 and divided by 9.81. That would get us a height of 10.204 meters. All right, and that is how we can solve this problem. Now, just to make sure that we got this, the information that we got was in this very first point, we got this energy, we got the potential energy. In point B, what we were missing was our velocity. Same thing as point C, we were missing our velocity. And in point D, we were missing our height, which is the maximum height that we're going to get to. Okay? So hopefully this video helped a little bit to understand the concepts of work, power, and energy. And thank you so much for watching. Have a very, very nice day. See you soon.